So let's make a geometry, guys. First, let's make a planar. Let's make a planar patch. Let's reduce this number. Let's actually I will reduce it more. And then let's make a test big head like this. Let's see how big is it. Let's make it small, 0.5, maybe much smaller, 0.2. Make it 0.3, and maybe I will transfer like this, and also this one I will make it 0.5 maybe. Yeah, 0.6. Okay, looks good, but maybe I will make it a little bigger, something like this. Okay, then let's make a Vellum constraint class. Let's connect the big head here. Let's make a Vellum solver, and let's see what we got here so far. Expect, hit enter. Okay, as we can see here, we have this simulation. Looks nice. Okay, so let's talk first about the compression stiffness. What is the compression stiffness? Simply, compression stiffness, when we reduce this number, it will make the folds unable to create folds. For example, let's take this one here, Control C, Control V, just to see the difference, to compare. And this one, maybe we'll make the 0.2, make it 1, make it 1.5. Okay, and this one also will be 1.5. Yeah, and we will merge those two to see the results. So this one will play with the compression stiffness. For example, we'll make it 1 to see the difference. Let's hit play. Okay, as we can see, actually they look same. Let's hit play again. Yeah, here we can start to see the difference. Here we don't have any fold created. It's more like it's not able to make a folds, right? If we see here, it's more like a wet cloth that when it's drop inside any object, it takes its shape without making a floats, right? As we can see here, maybe we can increase this number more to see much more. Yeah, so as we can see here, it's very obvious. So since we have a scale, maybe we can make the compression stiffness scale as we did before. We will go here, we will make attribute paint, and we will stand here. We have 0 and 1, but before that we will make another attribute triangular. I will tell him if at compression stiffness equal 1, hit enter. Then here we go to attribute, we paste it here, and we will start to paint. I will make it here 0.1, so make it maybe like this. So half of it would be 0.1 and the other will be just 1. Okay, let's just make it small like this, and let's focus in this one more now. Let's forget this one. Hit play. Yeah, or you know what, maybe we can make this 0.01 to make it very like this, and we'll stand here. Our damping ratio, we are here in the stretch. Yeah, okay, let's check again. This is a different. I think we have a faults here, but as we can see here, we don't have any faults here. So this is general. The compression stiffness, it prevent to create fold. Okay, so let's make a geometry. Let's make again a planar patch. Let's make it 0. Let's reduce this number, maybe reduce it more. I want more. Okay, this is for a second. Let's make a transform, and this transform, I'll make a keyframe here, and after 24 I'll make 4. Okay, then let's make a vellum cloth and a vellum solver. Hit escape, back L. Okay, so here of course it will fall. We just need to pin it first, so let's pin it. Space 2, this one, and also this one, and hit enter. Now we pin it. Also let's make a match animation. Space 1. Let's see what we got here so far. Yeah, so as we can see, it stretch, but it give us this arrow look that we have pressure here. We don't want this one. Maybe we can change it to triangular stretch. Yeah, triangular stretch is much better for just this example. Also let's increase this number to 0.1. okay, so now let's talk about the stiffness drop off. Okay, what is stiffness drop off? Simply, it's a stiffness drop off in certain number to 0, meaning when stretching reach this number, it will decrease suddenly to 0, and this number relative to the receipt length scale. Okay, of course we know that receipt length scale control the stiffness. Okay, so let's see, for example, if we make the stiffness drop of 0.05 for example, and for this one I want to make the sub step 5, and let's hit play to see what we have so far. Yeah, looks fine. Maybe we need to increase this number a little more to see what we have. Yeah, so as we can see, yes, now it's started to, as we can see here, it started to break. This will be 0 and this will continue to be 0. Now it's break the constraint. That means it will there will be no constraint anymore. Okay, meaning it becomes 0. We don't want that. We want at least minimum stiffness, so it doesn't break at all. Because if the stiffness becoming a 0, it will keep falling forever. Okay, the constraint is broke, and this will fall forever. So we can make at least minimum stiffness. For this stiffness, we will make a minimum for this one. Okay, so when it's going to break, it's not going to break to 0, but the stiffness will break to 0.05. Actually, I cannot see much about the 0.05. Maybe I will make it, let's see, 0.1. What's gonna give us? Yeah, so with 0.001 it give us something. Let's not forget that as much as you increase the point here in the patch, as much as you will have to reduce this number much more, because when it's going to stretch, it will have more points to prevent the complete stretch, or prevent to reach this stiffness drop off number. Okay, for example, if we let us make a little change here, but before that, let us go to visualize distance. Yeah, as we can see here, this is the area that the stretch or the stiffness drop off happened inside it. You know, this effect, it's like a jacket or something strip away or something like that. Okay, I don't even know what's meaning of strip away. Anyway, but you got the idea. Okay, that it's cut or something. Okay, it's a plover or something like that. So for example, let's make this 5, and let's hit escape back. Let's hidden this one. Also, let's change those, because we change it, so I have to rebuild again the pin to animation target. Of course, this number will be very big for it, so it will damage much faster. Yeah, as we can see here, it's damage much faster. Yeah, we have something here. It's happening all over. Maybe we can control it by this. Maybe we can make it 0.5. Let's see if we make it 0.5. So the minimum stiffness will be much stronger. As we can see here, it has more resist. I'm sorry, resist. It resists those. And now let's test the stiffness to see uh, when we change it, what the change will happen when we change it. Okay, I will make this a little more, so it will, yeah, it will rip more. Okay, as we can see, and let's increase it, for example, 1. Let's see first what's going to happen. As we can see, it looks much better, to be honest. But in general, this is all about this stiffness drop off. This is a stretching. Okay, so when we decreasing the stiffness, as we can see here, less stretch is going to happen, right? So I think we will have more uh, less stiffness drop off. That's what I want to say. less stiffness drop off will happen when we reduce or decrease this number, because it's depend on the stretching, right? Not the stretching itself, but you know, I think I explained it. I hope it's become clear now. Let's get it back again as it was before. Let's make this 0.5, and also let's control the stiffness drop off by the stiffness. Okay, we can control the area that we can that it has stiffness drop off by this stiffness stretch stiffness. Okay, if we copy this one, and I think I'll put it here, but first let's make attribute wrangler. So we have if at stiffness equal 1 like this, and so let's make add attribute paint. I will say in a second why we make this one, and let's choose the attribute. It will be the mask, and as we can see here now, this is red. If we delete this one or disable it, it will be like this. Let's see more. If we go here and choose the marker, yeah, so basically the attribute paint, it gives us 0 background and 1 foreground, or whatever the value that we put here both. Okay, so when we make first attribute triangular stiffness stretch stiffness equal 1, this means all the polygon will have 1, and then we can put here what the value we want. Okay, but first I will make it back again to color to be much easier to see. Let's choose this, let's make it a little small. Let's make some point like this. Yeah, maybe something like that. Okay, let's go here again and let's hit play. So we have stiffness, some area has 0.1 and other area have 1, meaning this value will multiply in this value. Okay, so again we will have 10% in the places that we make it 0.1, and full stiffness in the area that it has stretch stiffness 1. Okay, so let's see if it's going to stretch in the area that we choose. Yeah, I think it's, to be honest, it's hard to tell, but maybe if we choose stiffness drop off, maybe 0.1, 0.005. To be honest, it's hard to tell. You know what, maybe we can make something different. Maybe I can make this like this. Let's make this one. Yeah, maybe something like this. Let's see if I only make this 0.1. Let's see again. Oh, okay. Yeah, because we have to. Okay, let's check again. A little change happened, as we can see here. Maybe if we increase this one a little bit, and maybe we can make this to maybe 1000. Not exactly, but anyway, this is how it is. Okay, we will take another example, but first let's make this again like that. We'll make a compound like 2. I think we don't need those two anymore.